Today we are looking at lesson 4.1, part 2, or 4.1b. Our goal today is to find and interpret the maximum and minimum values of a quadratic function. We'll also be determining the domain and the range of these quadratics today. Okay, carrying on from where we left off yesterday, some important things are you're going to have either a maximum value or a minimum value depending on whether the parabola opens upwards like this. This would have a minimum value at the vertex, or whether the parabola opens downwards like this. It would have a maximum value at the vertex. Okay, so that's what we're looking for, is whether it opens upwards or whether it opens downwards. That'll tell us whether it has a minimum or a maximum. Okay. All right, so when we take a look at this little problem right here, let's go back to this one. Okay, some important parts of this, back to this. When we take a look at the parabola, this term in front of x squared is the key term to tell us whether it opens upwards or downwards. If that number in front of x squared is positive, right, then this thing is going to open upwards like this, and it's going to have a minimum. If that term in front of x squared is negative, then it's going to open downwards and have a maximum. Fairly simple little process here. So, on this problem, our goal is to, arrow going, consider the function negative x squared plus 2x plus 3. Determine whether the function has a maximum or minimum value. Well, quite simply, since that's a negative sign, we know that it's going to do this, and so it's going to have a maximum value. So our answer here is maximum. Alright, looking at this one, same type of situation. Since that's a negative, it's going to open it downwards like that. It's going to have a maximum. Alright, now when we're taking a look at the domain and the range of a quadratic, the domain of a quadratic function will always be all real numbers. X can be anything on these quadratics. The range is dependent on whether you have a maximum or a minimum. Alright? So if you have a maximum, the domain will be all real numbers less than or equal to the maximum. Now if you have a minimum, on the other hand, your range will be all real numbers greater than or equal to the minimum. Okay? So notice the key terms here are if you have a maximum, it's less than or equal. If you have a minimum, it's greater than or equal. Okay, so when we take a look at this function right here, all right, state the domain and the range of the function. In order to do this, first of all, we need to know that it's going to have a maximum. Okay, we need to be able to find that vertex point. So, to find that vertex, we're going to have to find our axis of symmetry. Remember, the axis of symmetry is given by x equals negative b over 2a. This is from yesterday's lesson. And in this case, b is 2. You can see b right there. Okay, so negative 2 over 2 times a. And in this case, we see that a is negative 1. One moment, please. Sorry about that. We had somebody come in needing some help. Back to the lesson. Alright, so we're still trying to figure out that equation for the axis of symmetry. And we can see that a is negative 1. So let's evaluate that. That's negative 2 over negative 2. Negative 2 divided by negative 2 is 1. So my equation for the axis of symmetry is there. And so what I know now then is that that vertex is going to be at the point 1. Now what I've got to do is figure out what the y number for that vertex is. So I'm going to be taking this equation and I'm going to be putting 1 in place of all my x's. So I have negative, and replace this x right. Going right. Replace that x with 1. Okay. Next thing, I'm going to be working with that one. Okay, so I have negative x squared plus 2 times x. Then I put my plus 3. Let's evaluate this. Okay, that's f of 1. So f of 1 is equal to negative, now 1 squared is 1, 2 times 1 is 2, and 3. So this is going to be, let's see, 5 minus 1 is 4. Okay. That is the location of the vertex. Now that I know the location of the vertex and I know that this thing has a maximum for my domain, the domain is all real numbers. The domain is always all real numbers. My range on this one, range is my y number, so my range is y, such that, remember, it's all the points that are less than that point, okay, the vertex point. So y such that y is less than or equal to this 4. And that's basically all you do to find the domain and the range. Okay. So now let's take a look at exercise 1 from your worksheet. Okay, determine whether each function has a maximum or minimum value. Find that value, then state the domain and the range of the function. You can notice you have 4 squares here. A would be determine whether a function has a maximum or minimum value. Okay, so first off, on this problem, I can see that my leading coefficient, that's what that term is called, is a positive, so I know that this is going to open like that. That means that this will have a minimum value. Okay? Now we need to find that value. Here's really where the real work comes in. Okay, let's use our axis of symmetry. X equals negative b. In this case, I can see that b is negative 1. So I've got negative 1 over 2 times a. And here I can see that a is 2. Alright, so what I have is basically 1/4. Don't you just love fractions? We're going to go ahead and figure out what this fraction is now by substituting 1/4 into my function. So f of 1/4 equals, okay, take out your x and put in a 1/4. Okay, minus 1/4 plus 10. Okay, time for the math here. 1/4 squared is 1/16 minus 1/4 plus 10. 2 times 1/16 is 2/16, which is 1/8. I'm going to go ahead and convert everything to eighths now to make my job easier. 1/4 is 2/8. 10 is 80/8. All right, so that should be a plus. Okay, so I have 1/8 minus 2/8 is negative 1/8. Negative 1/8 plus 80/8 is 79/8. Okay, now if you want to go ahead and convert that to a mixed number, you're more than welcome to. You know, I don't really care that much for mixed numbers, but if we do that, 79 divided by 8. Okay, it's going to go in there 9 times with 72 and a remainder of 7. So that is 9 7/8. I actually like the improper fraction better, but we're going to find that value of the maximum, and so that value is 79/8. That's as high up as it goes. Once again, you could use 9 7/8. Okay, so now once we've found that value, my domain is, what I said, all real numbers. Now, since this vertex is a minimum, it's going to be all the numbers that are greater than or equal to that 79/8. So, range is, open up your set building notation, y such that y is greater than or equal to 79/8. And there you go. That's how you complete the lesson for today. See you back tomorrow.